Chapter 8, Section 3, Trigonometric Ratios. So here's a list of all of our ratios that we'll need for this section: sine, cosine, and tangent. We think, and I'm sure that you've seen this before, of SOHCAHTOA whenever we're using these trig ratios. So stands for sine is opposite over hypotenuse. So you can see that if we're talking about angle A, opposite would be side A over hypotenuse, which is C, and that's what we have here. You can also see that when we're talking about cosine of, again, angle A, it's adjacent over hypotenuse. So adjacent means the line touching it, which is B, over the hypotenuse, which is C. So that's what we have here. And finally, we have tangent, which is opposite over adjacent. So opposite angle A is side A over the adjacent, which is B. And this is either to find an angle or to find a missing side measurement. But either way, it's only in right triangles that all of this was going to work. So you can abbreviate the ratios as SIN, still stands for sine, COS stands for cosine, and TAN stands for tangent. And this is a nice way to remember all of the trig ratios. Now let's try a few examples. So for parts A through C, you're finding the value of W to the nearest tenth. Well, we're finding the value of W, and it is a right triangle. If we're looking at this angle, which is 54 degrees, we have the hypotenuse and we have the opposite side. Well, which one contains the opposite side and the hypotenuse? That's going to be the sine. So sine of 54 degrees is going to equal the opposite over the hypotenuse. So we would do sine of 54 degrees equals the opposite, which is W, over the hypotenuse, which is 17. Then in your calculators, you would find the sine of 54 degrees, multiply it by the 17, because we're going to multiply both sides by 17 to get W by itself, and then we'll end up with our final answer to the nearest tenth, that W equals approximately 13.8 units, because we're talking about the side measurement here. So 13.8 units. Now make sure that your calculator is in degrees, because if it's in radians, you're going to get a negative answer here, and that doesn't make sense. So if you press mode and you go down to where it may currently say radian, go over to degree and press enter. And now you've changed it over to degree, so you should get all of the correct answers. Now for our next problem, we have the measure of this angle is 28 degrees. We have the side opposite it and the side adjacent to it. Well, which one has the opposite and the adjacent? That's going to be tangent. So if we do the tangent of 28 degrees equals the opposite over the adjacent, that means tangent of 28 degrees equals the opposite is 1.0, so 1, over the adjacent, which is W. Now this is a little bit trickier. We're going to still find out what the tangent of 28 is. But then if we were to multiply both sides by W and then divide by the tangent of 28, because I would multiply this side by W so that they cancel out, then I would divide by the tangent of 28 on both sides. I'd wind up getting that W equals 1 over the tangent of 28. So that's what I'm going to plug into my calculator and round to the nearest tenth. And I get that W to the nearest tenth is approximately 1.9 units. Now for our final example, we have that this angle is 33 degrees. We have the hypotenuse and we have the adjacent side. Well, which one contains the hypotenuse and the adjacent side. If we do the cosine of 33 degrees equals the adjacent side, which is W, over the hypotenuse, which is 4.5, we multiply both sides by 4.5 to get W by itself. And then we take the cosine of 33 and we multiply that by 4.5, and we get that W is approximately 3.8 units if we're rounding to the nearest tenth. So now that we know sine, cosine, and tangent for an angle, we can see that we can also use inverse to find the measure of the angle. So we use sine, cosine, or tangent of an angle in order to find missing sides, but in order to find missing angles, we're going to have to use the inverse sine, cosine, and tangent. So let's just try a few examples and follow along on your calculator. The first example A is looking for the measure of angle x to the nearest degree. Well, this is angle x. We have the opposite and we have the hypotenuse. Well, which one has the opposite and the hypotenuse? That's going to be sine. So sine of angle x is going to equal the opposite over the hypotenuse. That's what you can see here. We can reduce down 6 over 10, but you can't take the sine of x in the calculator. So in order to do this, we're going to do the opposite. So get x by itself by doing the inverse of sine to both sides. So it would cancel out on this side, and you'd be left with x equals the inverse sine of 6 over 10, which you can see here. In your calculator, you press second sine. That gives you the inverse of 6 over 10, which gives you this number. And then if we're saying to the nearest degree, that would be 37 degrees. Now this next example, we're looking for the measure of angle x, and we have the adjacent and the hypotenuse. Well, which trig ratio uses the adjacent and the hypotenuse? Cosine. So cosine of angle x equals the adjacent 15 over the hypotenuse 20. Do the inverse cosine function to both sides so that you can find out the measure of angle x equals the inverse cosine of 15 over 20. In your calculator, you press second cosine, and then you can write it as a fraction or as division, but make sure you have your parentheses there. You get that the measure of angle x is this number, which to the nearest degree would be approximately 41 degrees.